Alright, we are going to put in some work here so that we can find the derivative of the inverse of f. So we're going to be looking at derivatives of inverse functions. Okay, so one of the things I'm going to need to know is I need to know, does this even have an inverse function? So one of the couple things you need to remember about inverse functions is that an inverse function is just when you're swapping the input and the output, which is usually swapping your x and your y. And so if I add the 1 over, take the cube root of both sides, this should now be the inverse of that function. So I will need to know that, and then this was given to me. And this is a function because this would pass the vertical line test. Likewise, if you know what this looks like, and hopefully you do, if this passes the vertical line test and the horizontal line test, we say it's 1-to-1, and that would be another way to know that it has an inverse function without actually having to find it. But I'm going to need it in just a moment anyway. So to find the derivative of an inverse function, the most convenient way is to really just memorize the format of how it works. So the derivative, let's do this. The derivative of an inverse function is going to be equal to 1 over the derivative of the function times the inverse of the function. Okay, so if you want the derivative of not the function, because that would be easy, but the derivative of the inverse function, we need to divide 1 over the derivative of the function with the inverse function plugged in. So for us, this particular question, we're actually going to find that, and then we're going to plug in 26. Alright, so if I'm trying to find the derivative of the inverse function of 26, then this is what we're working with. So in place of x, I put in 26. So first I need to figure out, well, what if I plug 26 into the inverse function, what do I get? And then that'll give me a value, and then I can plug that into the derivative of f, which I haven't found yet, but I can do easily with the power rule, 3x squared. And then it will be the reciprocal of that because it's 1 over all of that stuff. Now, since I have found the inverse function over here, I can simply go back and plug in 26, and then this would be the cube root of 27, which would be 3. So all of this part is going to evaluate to be 3. Something else that is probably going to be helpful for us, though, is to remember how points interact between inverse functions. So for example, the function has a point of 326, which guaranteed that the inverse would have a point of 26.3. Because again, inverse, you're just swapping input and output. You're swapping x and y. Same way I swapped x and y to actually solve for the inverse. So if you don't actually find the inverse function, or finding the inverse function seems to be too much work, then you want to look at it like this. Instead of plugging this in for x, plug it in for y and then solve for x, because it can get you the same thing. Alright, so now the derivative of the inverse at 26. Since all of this comes out to be 3, now I'm interested in where the derivative is 3. So up here, let's plug 3 into the derivative. And that would be 3 times 3 squared, which would be 27. And so then that would give us 1/27 for a final answer. But hopefully what you can see is that you really want to be familiar with this setup, the format of how it works, so that you don't have to worry about that. It was helpful for me to actually find the inverse by swapping x and y and solving for y. I may be able to do it without on this question, but it certainly didn't hurt and it didn't take me very long. And there will be times where understanding that the x of the function becomes the y of the inverse and the y of the function becomes the x of the inverse. All of that was good information for me to get 1/27 as an answer.